This time we have ourselves a quadratic equation instead of a linear equation. Still going to do it the same way. We don't have to factor on this one because there's only a quadratic term. There's no linear term. So we're going to get that quadratic, that x squared by itself. And once we do, we can just take the square root of both sides. So add the 4 over. Divide by the 3. Whoa. Square just turned into a cubed. And then take the square root of both sides. So x is equal to plus or minus square root 4/3. Remember, whenever you take the square root of both sides, you should have both a positive and negative answer. And then let's break up that square root. Square root of 4 over square root of 3, still plus or minus, which is plus or minus 2 over square root 3. As we saw from a previous example, that's just plus or minus 2 root 3 over 3. On the trig side, do the same thing, except we're going to isolate the secant squared. So add the 4 over 3 secant squared x equals 4 divided by the 3. This is an equal sign. By the way, take the square root of both sides. When I take the square root of secant squared, I just get secant x equals, take the square root of this, just like before, I have the square root of 4/3, and break it up. It's like I did before, secant x equals plus or minus 2 over the square root of 3. Now, like I did on another example, just going to use the reciprocal property here and flip both of these sides over so I don't have to deal with secant. Instead, I can deal with cosine, since that's the reciprocal. So I'm going to rewrite this as cosine of x is equal to plus or minus square root of 3 over 2. Just flip both sides. Now, what you should notice, of course, is that this is two equations, two separate equations. The cosine of x equals positive square root of 3 over 2, and cosine of x equals negative square root of 3 over 2. So we have to solve them separately. Get ourselves a unit circle. On this first set here, cosine's x coordinate, we want square root 3 over 2, which is 30 degrees, or pi over 6. So if I use the radians, take all the coterminal angles, I get pi over 6 plus 2 in pi. Cosine has the same value down in quadrant 4. Yikes. Quadrant 4, which is 330 degrees, or 11 pi over 6. Take all its coterminals. Okay, so all of these solutions for that part of the equation. I have to do the same thing over here for the negative square root of 3 over 2. On the negative square root of 3 over 2, over here in quadrant 3, which is 150 degrees, or 5 pi over 6. And then down here in quadrant 3, which is 30 degrees beyond 180, so 210, which is 7 pi over 6. So let's add all of these solutions in here. X equals 5 pi over 6 plus 2 in pi, and 7 pi over 6 plus 2 in pi. Lots of answers. Let's say this is one of those type of questions that we just wanted it over the interval from 0 to 2 pi. In that case, I would just list out pi over 6, 11 pi over 6, 5 pi over 6, and 7 pi over 6. The end.